in this video, we'll be solving this limit. So first thing to notice is that as x approaches negative infinity, the numerator becomes positive infinity. The denominator goes to negative infinity. So typically, whenever you have infinity over infinity, you'll be using L'Hopital's rule. But for the purposes of this video, I will not be using L'Hopital's rule. So I'm going to solve this limit algebraically. And the way I'm going to do this is by bringing the 2x plus 3 inside the square root. Before I can do that, I have to notice that 2x plus 3 is negative as x approaches negative infinity. And the numerator is positive. So I would expect my limit to be negative, because a positive divided by negative will give me a negative answer, assuming the limit is not 0 or infinity. Okay, so let's bring in the 2x plus 3 inside the square root. So that's where we have to put the square. And notice I'm going to put a negative outside here, because remember, this right here, the square root, is positive as x approaches negative infinity. And so I have to multiply with a negative to get a negative limit. Now I'm going to distribute the square. So 2x plus 3 squared becomes 4x squared plus 12x plus 9. Okay, now I'm going to divide everything by x squared. So every term inside the square root will be divided by x squared. So we get this. And now, as x approaches negative infinity, each one of these is going to go to 0. So we're going to be left with negative square root 2 over 4, which is negative 1/2. And now I can break up the 1 and 2. So it'll be basically square root of 1 is 1, and then you have negative 1 over 1/2. And then I'm going to rationalize the denominator over here for this part by multiplying the top and the bottom by root 2. And that's where I get negative root 2 over 2. So either this or this is your answer.